Okay, so basically, I have a very grounded view of IoT. At first, I hate the term because it's well, it's a marketing term. But we'll get to when I think of the internet, I think of the best efforts infrastructure and connectivity. And of course, all devices should have some smart. So one of the new challenge that really makes Internet of Things is how do you connect things to each other? In software, we call this binding. Now, it's equivalent to wiring, but no, you don't need wires. You just need to set up relationships. And I think that's part of what makes this transformational. So this is an interesting device. It's made in Bulgaria. It's about this big in real life. Costs about $10. Open source, has web server, can be powered by 220 or 110 volts, or by 12 volts. Could detect contact closures, can control a relay. It's a maker device. It's basically, we'll see, it's an enabling piece. Nothing fancy, collecting data or anything. It's just a switch, as mundane as you can get. Now, this particular one is connected to the back door bell in my house. And all it does is detect, you press the button. Simple enough. Because the problem I'm trying to solve is the chime control is in the front of the basement. The bell is connected in the back. Now, I could pay to run a wire. It's a lot of work and money, and most of all, it's inflexible. So for $10, I can get a device, give it a URL, and it just connects to the front door. Now, you'll notice this is HTTP, not HTTPS, and we'll get to why. In the meantime, I've got to rely on perimeter security, which is a terrible idea. It's just better than nothing at all. And it's got a wired-in IP address rather than name, because we don't have that working. And these are key issues. In other words, we could talk about high-end policy and everything, but if MDNS, or local naming, doesn't work, then we're trying to solve hard problems without any grounding, rather than solving the immediate problems to make things work. But I want to, give you a real grounded sense. So this is the other end. Let's see if I can point, makes it easier. Okay, this device basically receives the message. This one has a fixed IP address. I'm showing it, but it's a deep secret. It's got the power here, and it gets the message and closes the relay here, which basically controls the chime. Very simple, 2 devices, and it's done. This other device is the front door. Now, it has the same power. It's got a controller, but it also got the wire which senses the front doorbell. The reason it goes through a device here is I could wire it directly to the chimes, but this enables it to be connected to the rest of the world. It broadcasts messages. I can add additional functions, and my other applications can listen in. So I can implement whatever policies. I can ring it. I don't know all the things I can do with it, but the point is this is such a simple and inexpensive device that I can enable the capabilities and learn later. Now, in reality, oops, go back. Where's the backspace key? Somebody hit the backspace. Okay, this is more in context because it has a Nest, and I've got to take the Nest signal, use a relay to turn the Nest doorbell signal into a contact closure so I can listen to it. And the point is, there's all this seeming complexity here that I basically reduced to the simple, I can send a message. So the important thing about architecture is how do you factor out the complexity? So I can wire this up, but I try to be careful using color codes, short wires. This is DC power bus to basically take the complicated, reduce the practice, and make it simple. Now, the other part of it is everything has to be inside my house. Samsung brought smart things which had a big cloud service and everything, but I used it to bridge all the Zigbee, Z-Wave, and other special devices. By the way, you notice one thing I forgot to mention on the slide here is this number. So if people are worried about scaling Wi-Fi, the answer is it scales. I'm using Ubiquiti, which is a higher grade thing, but I didn't even think about it. I was surprised to find I've got 180 Wi-Fi devices, most of them like light bulbs, switches and things, but it scales nicely. So this is equivalent to Samsung Smart Things, but it's entirely within my house, so I can bridge to other devices. So the house works autonomously. But what I really want to do is connect to the rest of the world. But I just want to mention the other problem here. So if I use a browser app to control my devices, and this pops up, because Google is optimizing Chrome. They want their version security, which is web only. All the DNS certificates are web only. So this is another one of the problems we have to face, which is why I have to use HTTP for now. My March column will be about approaches to solving this. The other problem you run, so let me now take a little time to sort of, I don't have the slides for it, and then I'll get to this. So the other point about this is I could take that doorbell signal, I could take that doorbell with me, put it in my pocket, take it anywhere in the world, and have it work. Now, what does that mean? Well, right now, I've got to put shims in, I've got to do port forwarding, I've got to do all these hacks to get that message, because the IP address isn't publicly available and all these kind of things. But because of the best efforts architecture, now what that means is what I do, I'm not relying on the network to actually create the connection for me. I'm not even being assured that there's reliable delivery. So since I'm not critically dependent upon a well-established path, I can move whatever shims I want in to make that work, and the application will continue to work. Now, that's not ideal, and we want to head towards a future where things can just work. So what I'm going to talk about in the next panel is, what if that device is not a doorbell, but is a medical monitor that's critical to my life? You want that to just work. So the best efforts architecture of the internet is important because it permits me to put anything I want in the middle of that connection. Firewire 39.4, you could not do that because it had a length limit. Zigbee has its local security perimeter. All these older sort of style protocols have these limits in because they're not just protocols, they're applications. The thing about what you call the internet, since the term is so confused, I'll call it the best efforts infrastructure, means I can extend these relationships because I accept the fact sometimes it can't get through. That's what makes them powerful. But the next stage is if I wanted to take the medical monitor, come here and stay alive, well, that can't connect because we already saw this. We were trying to connect one of the devices here. You can't get past the hotel agree screen. Why do we have these agree screens? The other, its cousin is the SSID security, perimeter security. So we have, the reason your Wi-Fi has this idiot security is that early PCs were not designed to be on the public internet. And we can secure the physical network, but once you had Wi-Fi, they became too exposed. So it's a quick hack, a patch. The SSID was added. But if you've got a secure connection, you don't need any of that. But that persists along with the agree screens and everything because people assume it's just the web, Facebook, you've got to have a person there. It breaks just works connectivity. But the other big problem, and the one I'm going to emphasize later, is that there's a paywall around the telecommunications industry because we choose to pay for it by preventing people communicating until they pay, I call it rent seeker along the path to pay a toll. And if we funded it as common infrastructure, suddenly we enable all these devices to just work. So the point of my playing with the doorbell is it's the simplest case. It's the one bit you could get from point A to point B. But that same approach then scales up to anything connected to anything in the world. But I'm starting with a very mundane problem, which I think helps you understand. If you can see all the parts there, understand what it is, you can then see how to build much larger things, rather than the flip side, where you've got, I'll mention 5G, which is a marketing agenda in search of a problem that is needed for. Here I've got a very practical thing that scales. But the other thing to understand is we use the word networking, so we have to be very careful. Networking is like a social activity, something I do for the intelligent device at the endpoint. Because we used to have dumb devices, we had networking as a service. And those are two very different things. So if we have an infrastructure which you just anywhere can assume connectivity, we can then explore what a real Internet of Things is, as opposed to, I don't know, some marketing Internet of Things. In any case.